Hello, this is Eric Ockman. This is Lab 1 for Fixtures and Workflow. So in this one, my computer's gonna run a little slow, but in this one, basically the goal is to drill a hole at an angle, but also perpendicular to this backside. So for this fixture, it's a slide in. Alright, well, my computer's really freezy right now, but it slides in, and then basically you have a pilot hole that guides it in to drill because it's at an angle, so it's going to deflect. So that helps prevent it from deflecting. And then once it gets in there, then you clamp down the clamp. I just kind of have a generic clamp throughout these, so not the prettiest, but it works for the idea. And then so I also have a slot to basically allow the excess metal to be able to work its way out. So that is the first fixture. So second fixture, once again, just generic clamp to kind of give the idea of a clamping mechanism. But so this plate needs two slots that are CNC'd. I'm assuming CNC'd. It's possible to also bring this in as a robot and kind of slide it into place. So if you look, there's three little standoffs underneath there. That'll help balance it out. I added it near where it's drilling, so when it gets pressed down, the forces basically kind of work with the little clamping, or the placers. I don't know what you'd call them. The bumpers, I guess. And then so there's the three bumpers on the bottom, and then there's the two bumpers on the side, and it has a little, kind of like a little slot to help guide it in, so it's not like rattling around and bumping up. But as this, if the kind of snags something when it retracts on the mill. And then there's a third little bumper just to kind of help guide that into place in that angle, and then a clamp to clamp it down. Potentially you could have a clamp on the other side to really ensure that it doesn't move in that direction too if it's not grippy enough. So that is fixture, the second fixture. And then if we go to the third fixture, so the third fixture, first I'm going to pull up a picture. So basically slotting a hole through the middle and then kind of adding this like outer ring on the outside. I guess maybe if you wanted to put like a bushing or something on, or not a bushing, rubber garment on the flange. O-ring, that's the word I was looking for. So if you want to like put an O-ring, so the idea I had here was basically to have the lathe kind of like like what a normal lathe would be, where it has the three clamps and then the electric motor, and then still kind of going with the same idea. Basically you work in, so the part's spinning and then it drills out the hole as you work this piece in. It's not really moving around. My computer's not liking this load. And then so that outer piece, that little that tool, kind of the same idea as when you're using a lathe, where you work that tool in, and basically that'll create that outer ring for that bushing or O-ring or whatever else is going in place in that flange. And then you wait for it to load. And then so for this one, do not have the ball mated in there yet, but so basically the idea is that the ball, we're freezing up again, but ball gets placed in there, and then that top crown, that top guy, clamps down. So will it let me mate it? Might be asking for a bit much, but so that gets placed down, and then there's going to be a bolt that cinches it down, and then like an upper, kind of like an O-ring almost, to allow for a little bit of play and give it a little extra grip, so when that hole comes drilling through the top, the ball doesn't go spinning around. And so yeah, for this one the goal is basically to center drill a hole and then straight down. So there's not going to be really any deflection when you're using a mill bit. So it has a it has a flat tip on it, so it won't bounce around. So as long as you get relatively center, it'll stay centered and be able to drill through. So the goal is just basically to make sure the ball's not spinning, and then it can accurately do it precisely every time. For the depth, the depth's kind of placed on the drill itself, so once you kind of have an accurate way of controlling it up and down, depending on the type of drill, it depends on if you put like a bump stop in the actual plate or hardware itself, but I assume that it's automated to some extent and it has something to control the depth itself on the drill. We are going to try to work our way to the last part. So for this last part, in this last part, basically a drill, like a end mill bit's going to come by and do a straight line across. So the main goal on this is to have it not wiggle around and then have pressure or have something to basically counteract the force that the drill is coming down on, because it's thin layer right there. So I created a block so that's able to push down, and then also since it is a block, then you're able to maneuver if it goes left or right more. This clamp helps just kind of cinch it into place so that things aren't really moving around. It's pretty sturdy, it's got its points of contact, and then little bumpers in the back. So yep, basically the drill comes down and works its way across. And that is this week's lab for fixtures and workflow.